Okay, we will be going through the LT12e Quicksort. Question 4 and question 5. These are non-in-place quicksort algorithm. For question 4, we will do the partitioning once. And in question 5, we will then do it recursively. Now let's go through the non-in-place quicksort algorithm. First, we need to choose a pivot. And in our discussion in this cosmology, we will be using the last element in the sequence as our pivot. Next, we iterate through the sequence and then append all the smaller value elements into the left list and then the larger value elements into the right list. Now, when we join the pivot, and the right list into a single list, what you will have a pivot, and all the elements on the left will be smaller and all the elements on the right will be bigger. Now, the next question in question 5 will require us to recursively do this step 1 and 2, choosing the pivot and iterating through, and then joining it back. Now, repeatedly doing this until the list on the left or the list on the right has one element or no element, then it will stop. That will be the base case for our recursive function. And with that, the list will be sorted as we described in the unplug activity. The process that we are using is known as a non-in-place algorithm because it uses extra memory to create the extra list, the left list and the right list, to perform the quicksort algorithm. Hence, this is known as the non-in-place sorting algorithm. We will use the following code to generate a list of n unique number. So we have a range from 0 to 8, and that will help us to generate 9 numbers, and we put that into a list. This list will be in the ordered from 0 all the way to 8, and we use the shuffle in the random module to shuffle the number in the list, and that will give us the random sequence. So if we're going to run this code once, we will actually get a random set of numbers. Let's go on to step number 1 on the partitioning the list once. So we will call this function as Quicksort. Let's define our pivot index. The pivot index is the last element, so that will be the length of the sequence minus 1. And the pivot value will be the sequence at that particular index, which is the pivot index. So that will be the pivot value. Let's define a left list, which is empty, and a right list that is also empty. Next, we need to go through all the elements in the sequence. If the element is less than the pivot, we mean the pivot value, we append the element into the left list. Else, append it to the right list. After going through all the elements, we shall return the left list. Let's say now we return it as a tuple. The left list, the list that contain only the pivot value, and the right list. Now let's do a quick sort on the random sequence. Now the pivot value is a 7. Whatever on the left list is actually smaller than 7, and anything that's on the right list is actually bigger than 7. But then you see that the element 7 is also included in the right list. Now this is not what we want. So what we do is that we actually remove the last element, which is our pivot, the -1 index. And what it means is that we will take the whole sequence except the last element, because the last element has been taken as a pivot. Let's run this. Okay, so pivot 7, everything that's on the left is actually smaller than the pivot. Everything that's on the right is larger than the pivot. Okay, now we, instead of returning as a tuple, we could have returned it as a list. Let me comment off this. and return as a list. If you want to return it as a list, you will need to join the list this way. There you go. 7 is our pivot. For question 5, we want to partition the sequence recursively. Now, in doing so, that will result in a sorted list. So let's copy the code from step 1 and paste it into step 2. Now, in order to do that recursively, let's assign left, calling the quicksort again on the left partition, and let's assign the right list quicksort the right partition. Okay, in this way, we would have recursively call the quicksort on the left and the right partition. Now, when we try to do the recursive call, we must always define our base case. Now, we will recursively call this quicksort until the sequence is one element or no element. So if length of the sequence is less than 2. Now, less than 2 means that it could be 1 or it could be 0. Return the sequence. Okay, so we have the base case to stop the recursion. And let's run the code. There it goes. The random sequence has been sorted in the ascending order. Now, please note that the primary advantage of a quicksort is because it is an in-place algorithm, okay, so that it doesn't require extra memory. But the one that we are going through with you is actually a non-in-place.